Hello, friends. Let's start with the next topic of the lecture series. Next topic is categories of cables. The Electronic Industry Association EIA has developed standards to classify the unshielded twisted pair cable into 7 categories. Categories are determined by cable quality with 1 as the lowest and 7 as the highest. Each EIA category is suitable for specific use. The table on the screen shows these categories. Coming on to the next topic, that is connectors. The most common UTP connector is RJ45. RJ stands for the registered jack. The RJ45 is a keyed connector, meaning the connector can be inserted in only one way. Performance. One way to measure the performance of twisted pair cable is to compare attenuation versus frequency and distance. A twisted pair cable can pass a wide range of frequencies. However, with increasing frequency, the attenuation measured in decibels per kilometer dB per kilometer sharply increases with frequencies above 100 kilohertz. Note that gauge is a measure of the thickness of the wire. Applications. Twisted pair cables are used in telephone lines to provide voice and data channels. The local loop, the line that connects the subscribers to the central telephone office, commonly consists of unshielded twisted pair cables. The DSL lines that are used by the telephone companies to provide high data rate connections also use the high bandwidth capability of unshielded twisted pair cables. Local area networks such as 10 base T and 100 base T also use the twisted pair cables. The next cable is the coaxial cable. Coaxial cable or coax carries the signals of higher frequency ranges than those in twisted pair cable, in part because the two media are constructed quite differently. Instead of having two wires, coax has a central core conductor of solid or stranded wire, usually the copper, enclosed in all insulating sheath, which is in turn encased in an outer conductor of metal foil, braid, or a combination of the two. The outer metallic wrapping serves both as a shield against the noise and as the second conductor which completes the circuit. This outer conductor is also enclosed in an insulating sheath, and the whole cable is protected by a plastic cover. Coaxial cable standards. Coaxial cable are categorized by their radio government RG ratings. Each RG number denotes a unique set of physical specifications, including the wire gauge of the inner conductor, the thickness and type of the inner insulator, the construction of the shield, and the size and type of the outer casing. Each cable defined by an RG rating is adapted for a specialized function as shown in the table. Coaxial cable connectors. To connect the coaxial cable to devices, we need coaxial connectors. The most common type of connector used today is the BNC connector, Bay1-Neal concealment connector. The diagram shows three popular types of these connectors: the BNC connector, the BNC-T connector, and the BNC terminator. The BNC connector is used to connect the end of the cable to a device such as a TV set. The BNC-T connector is used in Ethernet networks to branch out to a connection to a computer or other device. The BNC terminator is used at the end of the cable to prevent the reflection of the signal. Performance. As we did with twisted pair cables, we can measure the performance of a coaxial cable. The attenuation is much higher in coaxial cables than in twisted pair cable. In other words, although coaxial cable has a much higher bandwidth, the signal weakens rapidly and requires the frequent use of repeaters. If we talk about the applications of coaxial cable was widely used in analog telephone networks where a single coaxial network could carry 10,000 voice signals. Later, it was used in digital telephone networks where a single coaxial cable could carry digital data up to 600 Mbps. However, coaxial cable in telephone networks has largely been replaced today with fiber optic cable. Cable TV networks also use coaxial cables. In the traditional cable TV network, the entire network used the coaxial cable. Later, however, the cable TV providers replaced most of the media with fiber optic cable. Hybrid networks use coaxial cable only at the network boundaries near the consumer premises. Cable TV uses RG59 coaxial cable. Another common application of coaxial cable is in traditional Ethernet LANs. Because of its high bandwidth and consequently high data rate, coaxial cable was chosen for digital transmission in early Ethernet LANs. The 10 base 2 or thin Ethernet uses RG58 coaxial cable with BNC connectors to transmit data at 10 Mbps with a range of 185 meters. The 10 base 5 or thick Ethernet uses RG11 thick coaxial cable to transmit the 10 Mbps with a range of 5000 meters. Thick Ethernet has specialized connectors. Let's move ahead with the last category of cables, that is fiber optic cables. A fiber optic cable is made of glass or plastic and transmits the signals in the form of light. To understand the optical fiber, we first need to explore several aspects of the nature of light. Light travels in a straight line as long as it is moving through a single uniform substance. If a ray of light traveling through one substance suddenly enters another substance of a different density, the ray changes the direction. The figure shows how a ray of light changes the direction when going from a more dense to a less dense substance. As the figure shows, if the angle of incidence I, the angle the ray makes with the line perpendicular to the interface between the two substances is less than the critical angle, the ray refracts and moves closer to the surface. If the angle of incidence is equal to the critical angle, the light bends along the interface. If the angle is greater than the critical angle, the ray reflects, makes a turn, and travels again in the denser substance. Note that the critical angle is a property of the substance and its value differs from one substance to another. Optical fibers use reflection to guide the light through a channel. A glass or plastic core is surrounded by a cladding of less dense glass or plastic. The difference in density of the two materials must be such that a beam of light moving through the core is reflected off the cladding instead of being refracted into it.